Hey everyone, welcome to the Smart Metals live stream. This is the first time I'm doing this live on LinkedIn and YouTube. Every 2 weeks, we will be talking about digital transformation in the metalworking industry, construction industry, and anybody that does some kind of discrete metalworking. This is going to be the show where we talk about the best strategies, approaches, and technologies, how you can effectively transform your business. Hi, my name is Luc. My last name is Van Enkhuizen. That's a Dutch last name. Kudos to you if you can pronounce that. Today we're going to be covering manufacturing execution systems and what they are for, who needs them, and how I think about implementing those in your shop. So first of all, this is the same stream if you're Dutch as I did last week in Dutch, but a few adjustments and a few new updates. So make sure that you are tuning into the next one in 2 weeks if you want to get the English one. And next week I'll continue with a Dutch episode. Second thing is this show is going to be completely live, as always. So feel free to drop your questions in the chat. I will be here to answer them. I might pull them on the screen. Make sure to keep your questions general. Don't share anything confidential about your business, your suppliers, or partners in here. Everything I show you today or tell you today is purely educational, of course, and not any product recommendations in any way directly. I am independent. I have no stake in what you're choosing and everything I show you as well. It doesn't have any affiliations with me. And so a quick note, in the end, I will show you a product that I've built myself. This is going to call Eryxon. It's a MES solution, and that's where I will show you my vision, how I think any metalworking shop should at least start with, and then build their own capabilities on top of that. So let me see, everything is live. I see we have some viewers. Please let me know if everything is coming through correctly. Say hi in the chat. I will bump it up on the screen if I need to. But for the rest, I think we are good to go here. Let me check a few more settings and then we're going to really hit it off. So, hello everyone, and let's go. So, quick about me. Let me quickly pull up here our today's presentation so that we can all tune in there. So let me start by this one here. Let me see if we got this right. So I guess it's taking a few seconds to get it all going. Yes, there we go. Good. So the title of today's presentation, as I said, it's Manufacturing Execution System. So this is the layer that lives between your shop floor and your ERP system or business systems. And in short, we call this MES. This is made for metal fabricators, construction companies, and beyond. If you do anything turning raw materials into semi or finished products and your business is somewhat discrete, this is going to be for you. If you're doing continuous production, this might be relevant for you, but some parts might be different for your business. As well as if you're not doing anything with metals, but for example, you're doing furniture design, there's a lot of some overlap here, but the product examples I'll mention, technologies will be a little different. That being said, let's start with the idea of it. So I've spent the majority of the last decade doing anything with systems integrations in the metals industry. That means I have been working on implementing ERP system, expanding the functionalities, integrating that with shop floor software or machine software, for example, order pools of machines, and building these capabilities in these companies to organize their data, get a better overview of what has to be done, and help these fabricators to bridge the gap between planning and what actually happens on the shop floor. Now, I think we all know the picture that we see here in the left. I think the majority of metal companies nowadays, they still work with these paper travelers. This is called a like a work instruction paper that goes into the shop. And often you see quite a lot of people in offices doing a lot of data entry into the ERP system to first of all get the data in there, and then they will manually print all these documents to then give them to the shop with probably drawings with it, which then have to be organized then by dates and go into all kinds of folders. And the majority of the companies I speak to, they do this because maybe because they don't know any better, but mostly because they want to convey information to the floor that they cannot really easily place in a system. And some companies have maybe started using some kind of shop floor control software, meaning some kind of app that they used on top of the ERP where people then can start and stop and track. However, these kind of software systems are generally quite expensive for manufacturers. They're not the flexibility that they are really looking for. And my experience over the last decades is that most of these ERP-based systems are too generic, and the other ones also very specialized, and there's always something more that you want. Now, over the last years, I've been doing a lot of trainings and workshops with companies, and this topic of MES kept surfacing up every time. The question is like, how does it work? What makes it better? And how can we actually take this old school paper travel system with all the paper documentation and all the issues and turn this into an integrated digital system? And today we will be talking about specifically that topic. And honestly, I don't think most companies have really a clear answer why this is. Maybe you have a clear answer for yourself in the chat why you have your own reason to say paper if you still work paper-based, and what you are looking for in a software like here. So let me start here. First of all, let me start by saying that an MES system is not per se a software system. And then I will start explaining the functionalities that I think you would need to get going. So let's continue with the next stage. You know, in the world of metalworking, your production really never stands still, right? And because your orders keep changing, your work orders keep changing. The moment that you are releasing this work order into the shop floor on paper, it might be that the schedule already has changed. The customer wants a last minute revision. Maybe you found out for a similar part currently in production that has some issues, and you don't want to have that issue recur again in the next batch. Because of those issues that can arise in real time, paper is always already outdated the moment it rolls out of your printer. And you don't have the ability to make this interactive. You usually have only a couple paper fields, and by the time that the information gets back to the floor, it's usually already too late. Imagine there is some issue with quality, or there is some rework to be done. You will find this out too late by the time that it ends up by the shop, at the exit of the shop when you deliver to the customer. And therefore, paper is basically a problem here. This also goes for example, setup plans for laser cutting and bending and so forth. You will always find that the moment that you have created a nesting or some kind of like laser job or a batch, the moment that you have prepared that batch, you printed it, you put it into a filer. By the moment you start producing it, ideally you would like to have that flexibility to change things. And not to mention that this is all quite limited. It doesn't show you detailed issue tracking. So what does MES solve for you? I think, in my opinion, an MES, and this is also inspired by what Walker Reynolds teaches for 4R Solutions, who I've been in the trainings with for the last 2 years. And I really agree with his core 4 approach of MES. So some credits given here. However, I will add a few twists here that I think are particular to metal fabrication and metalworking. And let's start with at its core. So an MES basically bridges the gap between planning and production by providing real-time insights and control. At its core, its MES offers fundamental functions commonly known as these core 4 functionalities. So consider these the baselines. These are the minimum requirements that are tracking your production orders in real time, planning those production orders in real time, then measuring them by terms of how effective did you do that? Was the machine running? Was the workplace running? Was production going well? And did anything occur during production that kind of deviated from that? Was there any downtime, or particularly was there any issue with quality? With downtime, I also take in consideration here quality concerns or rework or anything like that. So let me start with the first one. I think every company, if you're going back to the previous step, they have these private travelers. And some of them have maybe some kind of shuffle control with limited apps. However, so you want to do this in real time. Now, you want to have everything in there, not only your work orders, but also all the steps and all the relationships between all the steps for the next and the previous steps, and seeing where they stand in terms of production. And to zoom into this here a little bit more, because MES is basically a set of functions, there is not probably going to be one software that's going to do all of this perfectly, but there is one kind of software solution that you have to create in your business, whether through an app, whether through something that you can extend, that you can real-time track what's going on of the real-time order in real time. If you don't have this in this year, 2026, and you're still doing everything paper-based and everything is still in one ERP system, for example, the first step that I always say to every company they must do is to digitally show and track every real-time order. And if you don't have this in some kind of dashboard right now, that you can see exactly at this moment where each order stands in your process, which department, this is the step one for each company. I've been solving this problem for a decade, and the first thing I did when I was still working in the office as a work preparation and engineer, I solved this by just doing simple time orchestration. And a lot of ERP systems can do this already. However, now we get to part two. I told you the word planning. And when people think about planning, they think about a high level Gantt chart with everything that's going on. However, when we talk about the MES kind of planning, what we are looking here up, in my opinion, is not really the MRP run, but we're looking at the fine-grained scheduling. So not the macro plan, but the fine-grained layer. So basically shift by shift adjustments or hour by hour adjustments, literally the stuff that most of the operators at the machines do with spreadsheets, physical papers, when they talk to each other, is really the day-to-day fine collaboration that manufacturers need to do, and helping them do that effectively. So what you can imagine here, what has to happen here is that you take what is scheduled, which has an end date and a start date, and reshuffle this on day-to-day group things by similar properties like materials and thicknesses and for batches and those kind of things. And this also allocation of your personnel, right? So what do you do when an operator is not there? Do you then put another operator on there, which leads into all kinds of specialized solutions such as competency management, so checking who's eligible to do certain steps or not. And when you have all this real-time operator data already in your system because your business is real time, it's much easier to do that real-time planning. And you will see that this is already not really working in most ERP systems nowadays, because they are really meant for the MRP run, the longer term scheduling of everything. But you have to adjust day to day. And that's why usually a lot of ERP-based MES kind of approaches fail. Now let's go to the third step here. So let's say you know now what you're doing in real time. You know who's working in real time. You know which operator and machine is there in real time. Now you also know the schedule and you can change the schedule. This gets to the third point. Now you want to make sure did actually the process go in the way that you expect it to be. And I think the most comprehensive metric for production performance is called OEE, and it's called overall equipment effectiveness. This is based on three core words: availability, performance, and quality. Meaning your availability is how often could you have been producing. The performance is when it is running way at the target speed. And the third one is the quality is of what you made. Was it good? How many good parts were there? And this can be turned into a formula showing you then exactly what you need to be doing. Despite the word equipment, you can apply this to anything. You can apply it to a work cell, you can apply it to an operation, you can apply it to an individual welder standing at the workplace. It can be a robot, it can be both, it can be all in between. In my experience, nobody actually really calculates this. Colloquially, it's only a handful of excellent manufacturers that are doing this at the highest scale, that have some kind of overview of this, but many manufacturers don't capture this. Most ends up on paper and then being scrapped afterwards, or they only look on the total hours worked, but they miss that key combinatory formula to really get a solid number, which could be their Northern Star for their improvement. So it's super valuable to have this third step. And the fourth step here, let's go back to what we have so far. If you know all this information and you want to know the quality, the third step here, to get the quality, you need to know what is then good part, what is the bad part, and operators need to report this. This is often already done normally in a lot of manufacturers, but they don't have the solution in place to clearly distinguish what has to be done as a result of that. Do we have to produce again? Can this be done on short notice? Is this within the boundaries of acceptable rework or not? And the question is also, was there any downtime? Because you can see when an operator is at his workplace or when a machine is there, but there's a lot of usually dead time between jobs when the machine is having changeovers and so forth. Now, with the downtime registration, we're really trying to find out why was that downtime there? Was the material not there? Was there something wrong with the machine? Was there something wrong with the instructions for an operator? What patterns are going on there? And this threshold to log this should be extremely low. If you have to write it on a piece of paper, the operator has to really stop their work, write it down, and they don't really track from hour to hour those kind of details. They only look at the end what they produced. And between this is where the most information lies for improvement. And that's what makes it so valuable to zoom into this. And because this all feeds directly, and this all here feeds directly into your real-time planning. That's why it's so essential to have these four things work together as a whole. So let's being said, this is the core four. Of course, there is way more. There are like dozens of functionalities that you could expand upon this. And with my clients, I always go over a list of like 10 core functionalities for metalworking. That's going to be for another episode. But think for yourself, how many of these things would you like to do? And can you not do because your software has limitations, or you're still like you're bound to paper trails because that's how people used to work with, and you find maybe that you wanted to try this with an ERP, but they couldn't really do all these things, so you still ended up with some kind of hybrid solution. And that's where I think we can learn the most from. Because your process from getting a customer order all the way to delivery has a bunch of steps. Your step first is, of course, when a new customer comes in that wants a quote, which creates a lot of information already, right? You have to do some calculations, do work preparation, process the files, and so forth, which then end up going into your ERP. And usually that's where something belong here is some kind of black box. So step 4 till 6 from MES machines and dashboards are usually some kind of like black box where things don't being tracked. And that's why I think that we should really talk about the old school way of doing things and the new way of doing things. And I think that all these technologies must work together over a unified data layer. And that's what I call the unified namespace. Actually, that is something that I also got from my mentor, Walker Reynolds, which has been very inspirational for me to this. And over the last years, I've been implementing this. So technically, in every company, there are many solutions here that companies work with. They have on the core of their business, they have on the top usually the ERP system. Then they have machines on the bottom of the stack. And then they want to see things going over multiple systems. And this is where you already see the challenge of a good MES, because a good MES needs to know things about ERP, what is scheduled, as well as what is being done on the shop floor. And it needs to know maybe things from quoting or like information that was in 3D models. Maybe even actual 3D model needs to be loaded into it, which means some file storage. And thus, you're going to need a lot of information to get the right MES. And in my experience, the only way to really do this correctly is to then give all that information to your system and do not try to funnel this through the old school model of ERP. That's going to be extremely complicated to get your data out of it. Plus, it's going to be extremely costly, and it's not really made for this fine-grained granularity of minute to minute. changes. Which brings me to the point where I think there are like 4 routes to get your MES going, and that's what we're going to be talking about now next. So we are now in since 20 minutes, so let me wrap up this section here and switch to the more detailed explanations. There are 4 routes, and I hope everybody can see this correctly. Let me see if I can make this a little bigger for you guys in a sec. But the core 4 routes to MES are basically depending on your situation. If I started in the beginning, there is only one thing that you must have already. If you don't have this right now, this is your number 1 project. Don't get distracted with all the AI stuff. Don't get distracted with all the opportunities. If you cannot see right now in real time where your order lives in production, if you do not track progress of work steps, and you cannot track like how many hours have been worked on these things, that's what every manufacturer that does some kind of discrete must already have. And the way to get there is basically the simplest way, is usually taking an ERP expansion. So let's say you have Odoo or Business Central, or if you're from the States, you might use JobBoss, or in Europe, we use Ritter IQ. We have also European brands like MKG or even SAP. These companies usually have some kind of ERP module which allows you to expose your data to the floor, just like I've shown on the first step. The benefit of this is that you have one single vendor. You only have to order this, you have to activate it, and you can track what you need to track for step 1. This comes with benefits because it's speed, and it's already integrated in your data. Running out placing shop floor control of your factory is what a lot of manufacturers I work with have already done, which gets me to the point, what is some downsides to this? The downside is that if you do this, first of all, it's limited in terms of real-time abilities. Meaning you cannot really have full flexibility on real-time scheduling because everything has to go to the ERP scheduler. The second downside is that custom modifications are expensive or completely impossible, slow, and need to go through consultants that only access that source code. Even with modular ERP systems like Odoo, we still have the limitation that we have to work inside of Odoo and funnel all the data to an ERP system to get access to it on the shop floor. And as I said, you often need also machine data and sensor data or multiple machine packages to get the information you need. And then, of course, because of all that, and you only do the work order tracking, you still end up with a lot of Excel sheets to do transportation planning or things that you cannot really place, and not to mention about 3D viewers and models on the shop floor to get rid of the paper drawings. So step 1 for any company must be that order tracking. And if that is what you need and that's what you can start with, it's nothing wrong to start with ERP, but no, it's not going to solve all MES requirements. But that's good enough to start. Over the years, I've also worked with a lot of specialist apps. I can show you a couple in a second on the screen, but there is a lot of specific functionalities that vendors created that are highly effective in what they do. And this could be, for example, if I'm going to twist a little bit, could be software like I've had really great experience with software from Azumuda. This is not a recommendation to buy it, but for example, Azumuda does something really well, which is work instruction software on the floor. They also allow you to create basically a lot of MES capabilities inside your package, track work orders. And this is really a specialized solution for companies that do a lot of assembling complex work orders. There's also specialized solutions for planning. For example, in a Dutch company, it's called Propos Software. Let me open that for you for a second. That's also a Dutch created solution, also available, I think, in the English-speaking market, and there's quite a few of them here, which also creates shop floor apps. Now, this list is not extensive, and to be clear, there's probably many more that you could actually like choose from. The idea is basically the same. You have a specialist app that solves a specific problem and can integrate with your stack. Then you also have the third option, machine software, meaning that your machine MES is basically an order pool from your machine. And this means that You could, for example, have a machine from Trumpf. Trumpf is a leading machine maker of laser cutting and bending machines, and they have a software called nowadays Ocean, used to call it Fab. Uh, Fun story, I was in 2012 one of the first to implement Fab in the Netherlands in the shop, and we integrated that to our ERP. That's how I started my career actually, as doing the integrations. And this is, for example, a extensive package of planning and manufacturing software that you can use to integrate your shop. The benefits here are obviously clear. The machine integration is there from the get-go. Everything is there when you start. You also will have a single vendor for everything for that machine. Also, the benefit is that it's usually comes as a ready-to-go package with a lot of the MES core 4 things in it already. So if you do a lot of laser cutting, you often can achieve these results quickly. Downsides are obviously the vendor lock-in, because you cannot change anything, and it usually only works really well with one vendor. Let's say you also have a Bystronic laser, and perhaps you have a tube cutter from another brand, and you have also a welding software. You end up with a lot of different specialized tools, also for monitoring. So let's say you want to track for example, a turning and milling machine. Let's say you're into like, fine metal fabrication. Then you want to track your machine states. Now you need also a monitoring tool from that fabricator, from that company. You end up with like 5, 6 different packages, all have to be integrated with the ERP system. They have a lot of overlap. It's all really not doing it, and it's extremely costly. So this is the third route, which leads me to the fourth route, where I think that any company should really look into it. And this is really possible nowadays, since that we have the dawn of AI upon us, meaning that you can code your own solution. You can either use platforms like Ignition, which is a very extensive coding solution to create a monitoring and MES layer, which comes with a couple modules. And this is kind of the industry standard for creating your own MES capabilities. Now, you can do this for monitoring like continuous processes, but since Ignition also comes with Perspective, which is a module to generate your own apps, you are able to create quite extensive and highly advanced apps. Back to the presentation. So this is one way, but you can also code your own, and that's something I'm going to show now in the end of this presentation. Which basically you're building on top of open source libraries, and you're using the backbone of your own data hub, which I showed as the unified namespace. So I think in the last 5 years, this industry has significantly changed, and this is where I think the most value can be created on the long term, which is the most advanced solution. And this is something that I help my clients also with to achieve, to set up a data hub, a unified namespace, put the data into a centralized database we can control, and integrate that for the rest of the company. This means, of course, that you need to build that central hub first. I think doing it directly on ERP usually leads into performance issues. The ERP doesn't like it, or if you have a cloud ERP, it's tend to be quite slow for operators. As I said, you need a lot of extra information, and creating a simple dashboard is way easier if you control your own data broker and storage of that information. Now, talking about unified namespace, as I said, this is something I want to explore in the next episode. It's basically a real-time single source of truth for everything that happens in your manufacturing business. And this is organized in a way, semantically organized, that you know which cell, which operation needs what information. This is something that I will have to explain in the next episode, but please note that this is, I think, a fundamental architecture, especially for option 4. As I said, building your own. Which leads me to the last slide of this. So basically, if you do this right, then you will have your own cloud storage for whatever AI you want to do. You probably have some kind of administrative software like your ERP. You will have a layer where you capture all that information that lives between the shop floor and the ERP that you can do yourself or a combination that covers these core four, that can integrate with the factory floor, with the software that comes with the machines. You can choose to have monitoring tools of these vendors or directly connect to the machines. And at the bottom, you can then, of course, have your field logic, like all the sensors and all these things. And I think that this UNS layer must connect to all these levels directly. And this is what I've been doing over the last years, and it seems to be extremely effective. I am really blown away by the scale you can achieve by this. As promised, I have one more thing, and then we are done for the stream. For those that don't know, I also code for my clients as well. I've been doing a lot of integration work, and when the AI technologies came out over the last years, I wondered to myself, how hard can it be to make an MES that I would love? And what does it take? Because I want to teach my clients the same thing. Eryxon is designed specifically for that. I've created an MES that is having a demo in the cloud, but you can self-host it. It's open source. The code is free, meaning I don't have any interest in it, what you do with it. It's just a template that you can expand upon, or you can hire me to help you do that. You can also build upon this and make it better. You can contribute to it. And it's basically a combination of a lot of the things that I've been talking about. Of course, this is the first version, and we make it better. So let me show you what I mean. So Eryxon itself can be found on the website .eryxon.eu. You can just look around the page and you find documentation. If you hit demo, it actually will take you to the app. You can create an account for free at the moment. I give you a 30-day trial, and of course, this is still in development. But I just wanted to give you an idea. So this would be an MES system that every manufacturing company should have if they're into metals. And these are the core things that you should have in place. So when you log in, you see that you have your dashboard with what's currently at a glance happening in the business. You can see which work is in which department. Some things are Dutch here. I'm sorry about that because my environment is Dutch, but you get the idea. And you can monitor production. You can see which jobs are in production, which parts are where, how they are progressing in your factory in real time. You can assign specific operators to specific parts, which allows you to set like a specific instruction, meaning that the quality is going to be right. Specifically if, for example, as I said, an operator is not there or something is very complex. We have issue tracking, which I'm going to demo to you in a second. And we have a basic capacity view with a simple auto scheduler to set things based on simple hourly availability and more. So this takes away all the Excel spreadsheets that a lot of companies use. I think if you take all these things into consideration, you really get rid of like 5 spreadsheets. But it's even more important that I made it a specific operator view. So you could set the screen into a tablet or on the shop floor. Then you see basically in your current production cell that you're in your department. Let's say I'm welding, so lassen in Dutch is welding. Then I'm now at the welding department. I can see which jobs can be started welding at their buffer, which is coming up later, and you can see here what's currently in process. If I hit the in process, I get all the information that I need, which resources I need, if there's any dependencies on assemblies, and so much more, the operation steps. We can start the manufacturing by starting a timer on this. We can report the amount of goods that we did. How many did I make? I report now 10. And it asks you, is there a short of target? Is there an issue? I'm like, no, I'm just like, for now, this is my break. If I want to report an issue, there's all kinds of issues that you can report. And lastly, but not least, 3D. So in this app, I've also integrated a full 3D model view, which lives in your browser. So there's no installation necessary, works on all devices. It allows you to basically see the part in an intuitive way for you to and your operators to see what they have to do. And of course, obviously, a step file viewer also comes with a PDF viewer. Didn't upload onto this specific file, but you get the idea. Now, let's say there is an issue with this part, and I'm saying it's non-conformance, and I say the surface finished, and 2 parts were damaged. So please fix this up next step before shipping. The idea is that we then have this in an integrated system. So an admin only has to monitor this screen and can see all the issues coming in real time and decide what he should do about it. And they're saying assigned to John to fix this. And I say, okay, it's fine, it's medium, it's not a big deal. Some scratches on two of these parts, 2 parts, grinding, and we approve it. So it's that simple to see basically what needs to be fixed. And here you can see already some parts coming together: time tracking, issue tracking, work orders, daily scheduling. And this is, of course, the beginning. There's a lot more going on in this software, like real-time monitoring. We have also various integration opportunities, such as the API, webhooks, MQTT for real-time data. It also ingests, real-time data from machines if you want this to happen, and so much more. Now, as I said, this is a community open source project meant to be specialized for each company. I can help you with that, doing the backend for that. And of course, you can build your own based on this template, or just get inspired of what you might need. So I've shown you some features. There's way more to come. Some quick notes how this was built, mostly using various AI tools. I've started, of course, with my own idea and a list of requirements. I use Lovable for a lot of the ideas around this, but the backend is written, of course, with some more advanced, like, for example, Cloud Code and my own code reviews and some work to do. This leads me actually to the end of this presentation for now. I promised I would try to keep it within 30 minutes. I see I've been going a little over, but hope it was valuable for people to learn from this. Let me summarize this quickly. So MES itself is, as I said, it's a function, meaning that you can create it from various technologies. It's just describe you how you can go paperless and achieve digital excellence on the shop floor. The 4 capabilities that I mentioned are the starting points and can be expanded and should be expanded based on your business. And the 4 routes to get there are, of course, depending on where you stand. You have to choose between buying and building, renting and constructing. This all depends on various factors. In my opinion, it's stay always with step 1, real-time tracking, and then consider what else do you need. I think that the real-time unified namespace is essential for this. And of course, you can build way more than you think with nowadays tools, especially how the barrier of entry has been dropping steadily because of technologies. Lastly, once again, a lot of credits to Walker Reynolds and 4 Solutions for a lot of these concepts I've been teaching. Also, thanks to a lot of my clients and all the participants in workshops for your questions. And yeah, also thanks to the guys from UMH, United Manufacturing Hub, which provide an excellent starting point for unified namespaces. Now, this replay is going to be slightly edited, available on all channels. If you have any questions, you can reach out to me on LinkedIn here, on YouTube, or send me a message. My company is here to be found at vanenkhuizen.com or sheetmetalconnect.com. And you can find a lot more about what I'm teaching here, as well as various articles that I wrote about these topics here, if you are interested in any more of this. All right, this brings me to the questions. Is there any questions left for the stream? Please let me know, and I'm happy to hear from you. I will wait like 1 minute or 2 to see if anybody commented anywhere. Yes, so the question was where the links is. Yes, that's indeed the link as Eryxon.eu. You're free to use it as you want, just don't make a competing product out of it. And if you have any questions, feel free to reach out. All right, that will be it for today. I don't see any new questions coming in. Join us next time in 2 weeks. So next week I will do a Dutch version. It's because I readdressed this Dutch market primarily. But the week after, you will see the same with a few tweaks in English. So make sure to be there. And we'll be talking about a bit more about the unified namespace. So I want to show you a bit more about what is a unified namespace for metal working in my fabrication. Some examples and some ways to get started. I'll try to keep it a bit more brief, but MES was just such an important topic that I decided to take a bit more time. All right, thank you everybody, and see you on the next show.